Good morning, class. This is Mr. Roberts, and today we're finishing up Chapter 8 with Section 8.2.3. The title is How Can I Use Exponential Functions? And today we'd like to look at solving a system of exponential functions graphically. So remember when we talk about solving a system, we're looking at values of the variable that make both equations or three equations true at the same time. So how do we find places where things intersect? And it just says graphically, so we'll be looking at some graphs. In this lesson, you'll apply your skills with exponential functions to solve systems of equations as you explore the values of cars in an investigation. So this is our primary problem today. It's called fast cars. For this problem, I've kind of stripped out things that I would do and say to you, obviously, because we're not in class together and you're not working together. But real simple, my expectations is that you will finish this table. We're going to start it together. You'll finish this table. You'll just click in these cells and type in it in your own notebooks. That you will come up with equations that model each of these tables. And then we'll talk about how you produce a graph in Desmos that you'll paste in this section. So when I open this up, I should see some kind of a graph here for all those functions. That'll be produced in Desmos. There's one other question below, question 117, that I'll also look at your response to, and you'll just respond to that here in text. So let's move up to here, fast cars. The moment you drive a new car off the dealer's lot, the car is worth less than what you paid for it. This phenomenon is called depreciation, which means that as time goes on, the car is worth less and less. Some cars depreciate more than others. That is, they depreciate at different rates, but most cars depreciate over time. On the other hand, some older cars actually increase in value, especially if a car has been, out for a while now. That's a rare collector's item. This is called appreciation. So there's three situations that are described here, and we're going to use some of the information given to piece together hopefully enough information to fill in the table and then also to produce equations. So Geraldine had a choice between buying a new Concorde EX for $27,000, a used Escalade that would have been $70,000 new if bought last year, or a 1967 Mustang for $18,150. Consumer Car Resources, all these are fake car names, fake companies. I guess they're worried about copyrights or something. Consumer Car Resource reports that the value of the Concorde depreciates at 6% per year, and the Escalade will be worth $672 3 years from now. It also reports that the appreciation of a Mustang has historically been very consistent, and it expects the trend to continue. And then here's some historical values for a 1967 Mustang. Not made by Ford, but I think made by Ord. It's the Ord Mustang. So off to the right, you'll see this table of values. And I did throw in some negative years because they talked about now, and then they talked about 1 year, 2 years, last year. So it'll give me some ability to put in some different values, and I have a column for each of the three cars. So the first thing I want to start with is it says a new Concorde for $27,000. Well, she's looking at buying one this year, so I'm just going to go ahead and right here, I'm going to type in that it's $27,000 if bought new right now. This car, they tell me that it is, let's just fill in the rest of the table and then we'll talk about some tips on how we come up with the equations. Let's go on to the Escalade. It says the Escalade would have been $70,000 new if you had bought it last year. Okay, $70,000 new if you bought it last year. So if I bought it last year when it was new, $70,000. And then it also says, and then it says, or a 1967 Mustang for $18,150. So that's now. So $18,150. All right, so there's more information here, obviously. In fact, if I look at this table, The Mustang, and I can zoom this out a little bit. It says last year from the table it would have been worth 16,500, and the year before that the Mustang would have been worth $15,000. There we go, $15,000. Also, it says the Escalade will be worth $28,672 3 years from now. 3 years from now. So this is this year, right? Last year it was $70,000. 3 years from now, that would be 1 year from now, 2 years from now, 3 years from now. It'll be worth $28,672. 3 years. Whoops, I don't need to do that. 3 years from now. So they've given us very different information. One of the things that they did tell us is that the Concorde is depreciating, going down in value by 6%. So if it's decreasing in value by 6%, that means that it's retaining 94% of its value. So hopefully you've got that. That means that my multiplier for that particular relationship is 0.94, right? So yeah, it's going down by 6%. That means it's retaining 94% of its value. So that's your multiplier. So if I think about this for this one, for the Concorde, I know that my multiplier, that's the value of B, is 0.94. So I can start, and I also have year 0 here, right? So I could take year 0 and I can multiply by that 0.94 again. I think I got cut off there again and again and again. So if I bring a little calculator over here, I can start with the $27,000, 27, 1, 2, 3, and I can multiply that times 0.94. So if I do that, that's the value of the car next year. That's 2 years from now, 3 years from now, 4 years from now. So that's a pretty quick model. The Escalade and the Mustang are going to be a little bit more involved. I will point out that if I start with $70,000 and I multiply that $70,000 by some value B 1 time, 2 times, 3 times, 4 times, right? So $70,000 times some B to the 4th power is going to equal 28,672. So if you write that down, you can think about, that's interesting. 70,000 times B, 70,000 times B to the 4th is $28,672. How do I solve that for B to the 4th? I'll remind you of division property of equality. And I'll also remind you that if you want to get rid of a power like to the 4th power, you can raise both sides to a fractional power that will make that exponent go away. And then finally, the Mustang, using these values, it's probably going to be pretty straightforward to figure out what your multiplier is. The question is, what do you multiply by to go from 15,000 to 16,500? And then from 16,000, what do you multiply to go to 18,150? Multipliers are probably it's probably the same there, or very close to the same value. And then you just continue on from that. We do know year 0 for that car, so that's nice. Remember, figuring out year 0 for the Escalade is going to be a little bit complicated because you need to know what the multiplier is and then use the 70,000 to move forward and get that. Once you have those all squared away, right down below you can type your equations in each of these boxes and just format those however you wish. I think if you do type them and select them, I showed you in class how to have OneNote turn those into math. And then the final thing we need to look at is, how do we produce our graphs? So to help you produce the graphs, right next to this, I've placed a link to an empty Desmos sheet that I've kind of pre-set up. So when I click that to open it, I get this. And you can see that there's room here for 3 different values from your table. So you can enter these and create like a scatter plot. Let's go ahead and enter. I'm going to just say that Y1 is the Honda. I have to say it. It's the Honda. This is the Cadillac, and this is the Ford. So the Honda was at year 0, $27,000. So I could just type in right here 27, 1, 2, 3. You can see it plays this graph here. The Escalate last year negative one, it was worth 70,000. 70, 1, 2, 3. Is that right? Yeah. And then there's the stuff for the Ford. So once you have those, the other thing that you can add that would make your graph look super cool is below, if you were to go ahead and type in the functions. So you can type in 3 different functions here. So clearly you're going to type in the table of values and we're going to see those dots. But if you were to type in like y equals, let's do the Honda. The Honda is $27,000. We said it's depreciating by 6%, so our multiplier is 0.94. We're retaining 94% of our value, and I'm just going to raise that to the x power. So there we see a curve that's modeling the depreciation of the Honda over time, and I can zoom out if I want to see more of that. Or I can zoom in if I want to see more. Another thing, remember in Desmos, that's nice is if you want to, where did everything go? If you want to change just the x or y axis independently, if you bring your cursor right over the y axis and you hold down Shift on your keyboard, you can then click and stretch just that one axis. You can see I've messed up my graph somehow because I don't want it zoomed in this much. There, that's better. And then also you can come in here and you can do the same thing for the y-axis. You can stretch that one out independently also. So you can kind of just optimize the view of what you're looking for. Anyways, once you're finished with that, I'd appreciate it if you would close the table off to the side. Just go ahead and do a screenshot of this graph only, and then just come back in and then paste that below in your notebook. So again, we're looking for finish the table off, right? Come up with the equations, paste in your graph, and then right here answer question 117 to the best of your ability. I'll read it to you. It says, as you saw in the Penny Lab, half-life applies to situations other than radioactive decay. In fact, the idea can be applied to anything that is depreciating or decaying in value. From the values in problem 115, fast cars, estimate the half-life of the value of the Concorde. So the question is, how many years will it take for that car to be worth half of what it was worth when you bought it new, right? So if it was worth $27,000, how far in the future do you have to go to find a time when it's going to be worth half of that's what half of 26 is 13,500. So how far in the future you have to go until the car is worth 13,500? So that's just how many years. Remember, a half-life is how many years something takes to cut its value in half. And then B, it says, according to the mathematical model, when will each car have no value? When will each car have no value? And I look forward to seeing your take on that question as well. That's it. That's all we've got for today. I look forward to seeing you during office hours. This is Roberts. Goodbye.